We're going to be talking only on a few aspects of the design today. I'll just give a brief introduction. We got Jessie talking about emerging technologies and our design considerations. Dylan's going to present on the solar and battery design. And then Cobe's going to present on our electric vehicle and bidirectional charging strategy. So this is a part of a bigger team. EPRI is the prime, Redwood Energy, we're a consultant kind of on a little bit of everything, but focusing on emerging technologies. PAE has been doing energy modeling and will be the MEP engineering. And then we're working with Mithun as well, who's the sustainability consulting and architect. And Janco Communities is the site owner. So this project, it's a California Energy Commission grant, and there's about 5 teams competing for the build phase portion of the grant. So it's kind of like a competition. And their purpose is to fund the design of emerging technologies and building system integration to enable zero net energy, all electric, transit-oriented, affordable multifamily communities. And this is just highlights of some of the project requirements. I think the biggest is what the design is supposed to achieve. So 50% reduction in tenant energy burden, a 40% reduction in embodied carbon, and a 90% reduction in operational carbon. Again, we're supposed to evaluate and incorporate emerging technologies. There's a lot of requirements around electrical load control. So eliminating net energy use from 4 to 9 p.m. Like tier 1 critical loads are supposed to run indefinitely, and tier 2 critical loads are supposed to run for 24 hours. 20% of the building's peak load must be able to be managed, and then all resident end uses must be controllable. So Dylan will talk more about how we're achieving that. Electric vehicles, so their requirement for the EPIC challenge is 20% installed EV charging. All remaining parking spaces must be EV ready. And then also there's a community aspect of it. So we're going to be working with the community to understand their drivers and energy use, indoor air quality, and energy burden as well. This is the site. It's in Petaluma. It's 131 units, and it's affordable housing. There's 3- and 4-story buildings. There's 138 parking spaces, and there will be a smart train station there as well. And we're going to plan for electric food trucks, and there will also be resident services as well. And with that, I'm going to pass it over to Jessie.
Thank you, Emily. Please bear with me. I don't want to have to hold 2 things like she was doing. Thank you. So researching for this project has been pretty fun and interesting, learning about different building materials and appliances. Fortunately, some of them were a little too pricey for our budget, but I think it's cool that the technology even exists. For example, we considered going with these building integrated photovoltaics from Mitrex. That decorative facade actually has solar cells that are generating power. At Meridian, we could have added over 500 kilowatts of peak power, but if you're looking at that price tag and thinking it looks a little steep, it's because it is, especially compared to all-natural thermocork that is about 1/5 of the price and way better in terms of embodied carbon because it's actually carbon negative. I think people are probably pretty familiar with cork as an all-natural flooring and as a layer of insulation. Thermocork's shiplap facade has all those same benefits. It's carbon negative, it's lightweight, it's mold resistant, it's flame resistant, and all we have to do is install it and paint it. And on a job this size with bulk pricing, we calculate that it's actually a little bit cheaper than using 3 inches of synthetic foam and fiber cement siding, which is not great for embodied carbon. So this was just a total win-win for us. Up next, we have the AFOCA. I think yesterday we kind of established that folks are pretty familiar with the AFOCA. So all I'm going to say here is that we went with the Pro. It's an upgraded version, slightly better specs. We did consider going with mini splits that would have had rooftop units, But of course, we need to max out our solar panels on the roof, and it was also more expensive. So again, the AFOCA just kind of worked out for us. And then I don't know if anybody talked about this while I was washing dishes yesterday, but I know that this is a real favorite in the retrofit game. As the name implies, you can literally just plug this into a regular 120 volt outlet. Doesn't require a dedicated breaker or anything. So that's why it's really easy to swap out a gas and use this as a replacement because there's no electrical upgrades required. The Hydro Boost piece of it refers to the fact that the water in the tank is stored at a higher temperature. And then there's an automatic thermal mixing valve that adds a little bit of cold water before it gets to the tap. So it's never scalding hot water. But this concept was really important for us at Meridian because we want to be able to do a lot of load shifting throughout the day or like at strategic times of the day. And by storing the water, starting it out at a higher temperature, you can kind of leave that tank sitting there for longer. Even if there's a little bit of heat loss, you're still delivering reliable hot water to the tenant. We did spec out 2 different centralized systems, but if you look down here, oh, actually it looks rather small. Hopefully you can see it. Just the equipment alone divided over the number of apartments, it was more expensive just their equipment than the installed price of putting a 120 volt heat pump water heater in each unit. So again, budgeting kind of determined some of our decisions. I didn't say sorry. Just stating facts. Induction cooking and affordable housing, heck yeah. Eating out is expensive. So people who live in affordable housing do tend to use their cooking appliances more than average. Thus, it is all the more important that it be incredibly energy efficient. I think everyone in this room, I don't know if I'll have to fight you, that induction is superior. It does require particular cookware, and we got a little bit of pushback that you can't assume that tenants will have the right cookware and you can't expect them to go out and buy it. So our solution is to just buy it for them. It'll essentially come with the stove, comes with the apartment. In the grand scale of, again, the budget, that one was really minor. So just, a set of cookware taken care of. Oh, and this one I'm pretty excited about. We looked far and wide, high and low, and found exactly one commercial heat pump dryer that is available for sale in the United States. The Miele PDR 908 HP. Unfortunately, it's not perfect. It's rather small. It's less than 5 cubic feet, whereas most dryers are more like 7 cubic feet. It's also about 3 times the cost. Fortunately, we calculate that with its superior efficiency, has a payback of about 7 years. I honestly don't really know if that's good, but it is what we calculated, and so we know that it's, it's saving stuff over time. But due to the higher cost and the smaller size, we did have to compromise a little bit. So only half of there'll be common laundry rooms and I think 14 dryers. 7 of them will be the Miele's and 7 will just be standard electric resistance commercial dryers.
If you're going to be off-grid, how are you getting the payback? How are you calculating that?
Emily did that calculation.
Yeah, that was just to, consider it as a technology, like why would they use it? And it's a lot more energy efficient, so it helps with peak loads and whatnot as well. But that's a fair point.
Calculate the cost, the payback though, because
electricity.
Did you compare it against the price of solar and batteries, or did you compare it against the price of grid electricity?
I guess it was just grid electricity. From the owner's perspective, though, they would end up saving a little bit, right? The tenants don't pay any utility bills.
Probably.
Yeah.
In alternatives analysis, the base case is always sort of business as usual, so it's fair to compare it against the grid electricity.
Yeah.
Thank you for the defense. All right, I only have one more slide, so I guess I'll hold this for that last one. And lastly, I just want to mention that there are large-scale, heavy-duty, commercial, I think one of these even counts as industrial heat pump dryers available in other countries. So hopefully we'll be seeing that soon in the United States. And on that positive note, I'm gonna pass it off to Dylan.
So I want to really stress before I start talking about the PV that we really did look at every aspect of this building in terms of energy efficiency, in terms of like flattening the curve, flattening the grid curve, so to speak, of our, what is effectively, what you're going to see is that we've effectively built a microgrid, but we don't quite get to call it a microgrid yet because we are working out with PG&E how much of the PV is actually going to go onto the grid. Long story short, we have 7 buildings. 6 of them are small, low-rise buildings, and then 1 of them is a larger 4-story building. The Title 24 baseline PV system is only 250 kilowatts of PV, and because it's Title 24 2022, we're gonna be required to put, because there is just that one building that's 4 stories, we would still be required to put 120 or 142 kilowatt hour battery system, which is basically only going to be enough to get you a resiliency center that could last approximately 72 hours. And so that's basically just a cooling center. All of those units, everybody's house is going to be off grid. And if I'm a tenant, and speaking to tenants, this is something that's a disconnect in the industry that isn't actually communicated, is like, I have solar on my roof. Why am I getting a power outage? It's not like we are in this industry are really familiar with the fact that you do need a battery, but most folks who get solar don't always end up with that. I've had conversations with several people like that they're surprised why they go off grid, or why when the grid goes down, they have a power outage. And so what we're going to be able to do, hopefully, with this project is deliver on that promise, that implicit promise of renewable energy, that no, you're not only saving energy, your landlord isn't only saving energy, now you actually get to be resilient as a tenant. And so this is what we designed. You're going to notice that it feels really, really big. Like this feels like a lot of solar. And that's because that's true. That's because this is over 1 megawatt of PV. This is 1,270 kilowatts of PV. And we're putting in a 2,000 kilowatt hour battery. With modeling, if we were to just try to take this building 100% off grid, we would need an 8,000 kilowatt hour battery just for those rare instances, which are really relatively rare throughout the year, when in Petaluma there's a winter storm for 3 days in a row and the sun never comes out. We have some strategies to get around that Cobe's going to address. But what we are able to do with this PV and battery system alone is be off-grid 95% of the year. And we only need a 200 amp utility connection. Effectively, we only need 72 kilowatts available from the grid ever. So we're not off-grid, we're grid sipping. We're like a hummingbird of the grid.
And when I contextualize, it is a lot of solar, it is a lot of battery, but if you make those all 131 home apartments into houses, that would be a 9 kilowatt solar array per house. It would be a 1 Tesla Powerwall per house. But when you combine all this together with all the diversity load, you start to be able to take it 95% off grid, which most houses, some would be able to do that, but the vast majority of houses couldn't pull that off.
And to be clear, 95% off grid means 95% of hours of the year. So in the middle of summer, like we can go 7 days without the sun coming out to a certain extent. Well, we can go 7 days off grid. We can't go 7 days without the sun coming out because the sun's going to be out. Thank you. And that is that is important because there are power safety shutoffs that happen in this area. It's an area that's been plagued by wildfires, and in the middle of summer, there can still be like black sky events. So being able to be off the grid actually provides them more resilience than the Title 24 baseline. even though we're only 95% quote unquote off grid. What's up with VPV? I'm just getting back to this. Why did we have a giant carport? Like the biggest carport you've ever seen? Because building integrated PV, which is the other route that we could have gotten enough PV, would have been not cost effective at all. Over double the cost of the giant carport. The giant carport after taxes is 2,500 a kilowatt, and building integrated PV is 5,600 a kilowatt right now, and it just doesn't provide enough energy on a per kilowatt basis. It just doesn't make sense for our project. But for some projects, for like code compliance, that can make sense. You know, if you just need a little bit more PV to bump you over, then that seems like a good idea, but just not right for our project. Not going to get too into the technical details of how our grid system works, but basically, in a typical home, you have two phases of power. You have two hot wires that come in. Each are 120 volts. And our project will be able to control one of those wires to turn it off. So because we've chosen equipment for the tenants that's all 120 volts, we get to pick what loads are critical and what loads are not critical. So we can control certain plug loads and certain things that can be off grid for a little bit and not create an issue for the tenants. Basically, we're trying to make this as smooth as possible for them so that if we do get into a situation where we need to shut down some critical loads, which again is like incredibly rare. This is a situation that only would happen if we don't have access to the grid and we don't have like PV for 3 days or so. So it's really uncommon for this to happen, but if it did happen, we do have the capabilities to start to ramp down our power usage. And in addition, this allows us to take advantage of demand response events if tenants want to participate.
How do you ensure that people with like medical devices, one, have access to power, two, know like
Right.
It's like one circuit in my house, like
Yeah, it's a tenant education situation, and it needs to be something that is opt-in for the tenants because it's demand response. Yeah, like that should be a critical load. Basically, is what I'm saying. Every tenant is going to have at least one 120 volt plug that's always critical. So.
But we do have two layers of resiliency: that's the grid connection and the battery, or multiple, and the solar array.
Yeah.
In multiple ways. Keep on going.
So basically, at this point, like it's really hard. I did that too. I had that same thought about this. Is like, are we actually creating more harm? But we're not, because the Title 24 baseline is no power. So in a grid outage, no power. But in our situation, if the grid goes down, we're still floating for a long time. You know, at least 3 days. So with that.
Shutting off one leg of the split phase is a brilliantly elegant, sneaky way to control that tier 2 critical load.
It wasn't my idea.
All 120 volt appliances, which is the newest thing that we can even do. Those appliances are new.
Right.
It allows us to set up a critical.
Right, and you can do that across the entire building with one circuit breaker.
Yeah, we
It's an emergent thing that we
Yeah.
actually discovered.
part of our reasoning there, we were looking at, the span smart panels as well, and then we're looking at, we could just do a sub panel that would be less expensive, and then we're like, okay, what if we did split phase instead? Is that kind of what led us to that decision? And that was the EPRI team that helped us figure that out. Yeah.
With that, I'll pass it along to Cobe.
Thanks. All right. So as Dylan stated before, currently we have a centralized battery system and a solar array that can handle 95% of the year hourly. So what happens with the other 5%? Well, currently our currently designed solution is a bidirectional EV strategy. So what this aims to accomplish is to help shoulder the burden of those winter days that you have consecutive low solar insolation, you have slowly draining centralized batteries, you can export some of that energy into a EV. So I'll move on forward here. Oops, I pressed it way too many times. Oh, perfect. Thank you. So essentially how our proposed design will work is during the summer months, we will incentivize vehicle to X charging. We will allow basically residents to plug in their bidirectionally charged vehicles, in addition to vehicles that the staff will own themselves that are bidirectional. And we allow them basically free charging and spots reserved for that specific thing. And all of that will be off grid as well. There will be about approximately 50 vehicles is necessary to fully cover that 5%, which obviously sounds like a lot of vehicles. But with the way that EV vehicles are being adopted, the rates at which they're being adopted, we foresee in the lifespan of the project that being a reasonable number, and using that grid tie to sort of offset whatever number of EV vehicles we are not able to connect to our system at this current time. Additionally, as I said before, there will be free charging for any of these vehicles during the summer months, just through curtailment. As we had mentioned before, this is an astronomically sized photovoltaic array, which means solar curtailment is also pretty astronomical during those summer months. So that chart down at the bottom, I know it's a bit difficult to see. So what we're looking at is essentially after all of the building energy demands are met, how much excess solar energy is being generated by that photovoltaic array. For sort of a comparison, we have a few lines on the graph as well that represent the 50 electric vehicles in yellow at the very bottom. Just above that, we see which one is that one? Yeah, so, oh, sorry, the yellow is the food truck. So in addition to electric vehicles, we have sort of an area reserved for food trucks. And those we have modeled can run perfectly fine using just the solar curtailment that we have available as well. So that yellow line represents food trucks. The orange is the 50 Leafs or Bolts or whatever bidirectional EV vehicle we decide to or is implemented. That's what's represented there. And you can see it is dwarfed in comparison to the pure volume of energy available during summer months, which basically for us just means we can guarantee that those vehicles can charge without issue. For the winter months, we can see a lot of curtailment as well, but it will be on a case-to-case basis whether or not people can charge their vehicles, or we'll need to basically access our secondary EV monodirectional charging stations, which will be grid tied. And then lastly, that gray line there, just for reference, is if every station in every parking space in the entire district that we are creating here is also tied into the system, we could easily actually handle that as well, just off of the wasted, quote unquote, energy that the solar array is producing on a regular basis during those summer months.
You can think of it as a resilient solar array. The reason it's so big is to make sure that we don't run out of energy in the wintertime. This is entirely a winter designed solar array, and all the stuff that we're seeing in the summertime is a consequence of making sure it works in the winter.
Right.
So we're trying to be like, well, how do we use up all this extra energy? Because we don't want to waste. And then the vehicle is such a great spot. Good.
But yeah, so an excellent point. The reason why we have such high curtailment is a fact that one is a safety factor. We want to make sure that we can provide that energy to the residents pretty much year round. And additionally, yeah, to survive, quote unquote, during those winter months where we have long periods of low energy into the system, and we have to, continue forward with that.
Did you think about, so David's strategy, you got me thinking about optimizing for winter? that in terms of limiting how much PV you're putting in?
Yeah. So, I mean, is this in reference to
Shading
the?
the tilt angle.
Oh, yeah.
Dylan,
I can speak on
Yeah, Dylan, if you wanna.
We did look at that, and the buildings are all essentially facing south. There is one west-facing array that I was able to put, because that is trying to get to that point, is trying to, in Petaluma, take advantage of like the setting sun is part of the best sun access. As far as the tilt, everything's 15 degrees. That's just what we found fit the most on the roof, but also didn't impact shading at all. The array, the final array design is only 6% shaded at most. So, we're maximized for like just having as much panels on the roof as we can, really, is kind of the strategy around that.
And another thing I forgot to mention, this wasn't our only concept for covering that 5%. We were looking at phase change solutions. We were looking at a wind power. But unfortunately, due to the conditions at Petaluma, the fact that windrows will show you there's almost no wind energy at this location. And on top of that, building windmills in the middle of a city is not exactly a great idea usually. But there are some emerging technologies that are worth looking into or supporting, like bladeless turbines that are still early in development, but could be applicable in a situation like this sometime in the future. Is it over here? There it is. Okay, so to look at it from a graphical perspective, once again, I realized these were much smaller on the presentation than I anticipated. But so to show you a comparison, the difference that these bidirectional vehicles make, I wanted to just sort of highlight the state of the battery. So the centralized battery that we have for this system is maxed out at 2,000 kilowatt hours, which is going to basically be that flat line at the top that is basically formed using this high resolution data or this high resolution model of the data. And we can see that on the left here, this is the base case scenario. This is without any sort of bidirectional vehicle contribution. Anytime that blue line touches the bottom axis there would be a day in which the centralized battery runs out, it fails. And we end up having to use other methodology to either curb loads or require more energy from the grid in order to function. So with this sort of introduction of bidirectional vehicles, on the right we can see that we do get fairly close once to exhausting our centralized battery. But with this preliminary model, even with the safety factor of like 1.2 for all of the energy demands of the building, this 50 vehicle system will prove resilient for the entire year. And so that's what the models are supposed to elucidate there. But yeah, I think that about wraps up everything I had to say about the
vehicle we did a lot of things in the research on how much electricity we can take. And so the number 50 vehicles is based upon about 12 kilowatt hours of lead in
Each.
that.
yes,
Yeah,
yes.
we take a day.
Very
Okay.
conservative. That's,
Right.
Right.
That's
Because
very hard for a skeptical challenge.
the batteries are coming out, and that was Jess's findings, like 74 kilowatt hour batteries is the average that we're seeing out there. And so
Yeah.
there's lots of 60 kilowatt hour batteries being sold in Volts and such. So very conservative. We could take out more energy and have less vehicles. So like, but this is the balance of how it's safe and doing effective.
Right. That is an important point to me. Yeah, David.
So let me make sure I understand this. This is really cool. So you're giving away power all summer long to people that
All year long. The sun is out.
all year long to people that are driving EVs because you're over-generating. And then when you have a bad day, you kind of deal with them. Hey, I'll give you free power, but if we have a bad day, you have to give us 20% of your power.
Right. Yeah. As a conservative, estimate, we wanted to basically provide a estimation of the power draw from these vehicles that would be less intrusive and also provide an appealing sort of compensation for that. So.
Great.
We did the math, it's like $1,800 of value in free charging gear for about $50 of value giving us electricity back. So that's the equity part. It's like we're gonna let people drive for free year round with the extra solar from our off-grid-ish apartment complex, and it'll just give us a little bit back. And I think Jessie found the surveys on what percent of people would participate with different amounts of money.
Yeah, and it's pretty high. I don't remember the numbers off the top of my head, but I want to say it was close to 90%, right? When it was
You got $1,000 bucks.
$1,000 a year.
See, doing that, right?
And 50% would do it for nothing. It's just a helpful.
Yeah,
Yeah,
just sit there.
that's just a virtual power plant. It's
Yeah.
a dynamic virtual power plant. It's great.
Huge batteries.
Did you have a question?
Yeah, first of all, great work. I mean, this is really impressive. Have you thought about mobility as a service for the 50 vehicles? So we're looking at a similar model because particularly in affordable housing to those of limited means, the cost of transportation is a pretty high expense. And so the idea of providing those vehicles as an asset of the property and then charging for their use and then effectively recalling them or not letting them out on the days, is that something you looked at as sort of a mobility as a service? And it's great you don't have to come up with the cost of the vehicle this way, but some, the resident did.
Right.
But
Yeah. I will speak on it a little bit, but I think some of the other members of our team can also speak on this too. We did look into sort of ride share or like communal vehicles that can be used. The main drawback obviously is the initial overhead, the cost of purchasing these vehicles, and then secondly, trying to regulate and enforce, the use or the control of when to use these vehicles as well, which makes it difficult. But yeah, I don't know if there's another point that you guys wanted to talk about.
Yeah, I can add to that. I don't think Danco, the owner of the project, wanted to own a whole fleet of vehicles in that way, because then they don't necessarily have a person that would manage that, I guess. But we are doing one vehicle to building Ford Lightning truck that will be owned by Danco. So, yeah, I think it came down to the cost of ownership of that.
That truck, by the way, that's a grid forming truck, so it
Yeah.
has to be off grid. It can't participate in vehicle to grid, but it has a huge battery, so this is why we're going to use it for the resiliency hub. If multiple tier things go wrong, then the community center has an F-150 that will keep it going for the community center and the cell phone charging and stuff. Day to day though, it's supposed to be the landscaping truck, and it has all the equipment plugged into it, so we can do decarbonized landscaping.
Yep.
Do you guys be thinking about like partnering, or I guess the planning board, do you think of like, if they're not winning the project, partnering with someone else that does something like, support something and seeing if they want to go to the market there, because they manage all the overhead and make it all the
Yeah, it's definitely a consideration, but yeah, I think we're relying on folks with EVs to come to the site, but definitely would be good. I don't think we had enough time to like find that partnership for this grant, but it would have been awesome to maybe we can investigate that in our next phase if we get awarded. Yeah.
Yeah, that's a really cool idea. Sean did sort of throw out the idea of using an electric bus and sort of some sort of partnership with the city and the transit system if they had an electric vehicle or an electric bus. Those batteries are huge, and we could offer them free charging during some parts of the day, and we just didn't really
I think Zipcar would have that oversight because they have everything.
Yeah, that's a really good idea that we just didn't really talk about specifically some sort of ride share, but we did sort of throw out some other ideas with partnerships. And I thought the bus idea was, maybe had some potential if they were going to be investing in that kind of bus anyway, but we can't really say like, hey, Petaluma, buy us this big bus,
And stuff like all that's taken care of by Zipcar.
Yeah.
That is needed is just the residents. And
Yeah,
they
that's a
don't
really
know
good
what it is.
idea.
So it's just like the Zipcar has had like, where we plug it in is like one of the main reasons why you don't have EV like one of the options. But they have like vehicles and stuff like that too.
Yeah, you're saying some good things. I like it.
So the other thing to consider is that if you do mobility as a service, right now, folks, at least around on the East Coast, are providing token numbers of vehicles. And I don't think anyone's going to feel confident not having a vehicle if there's only 1 or 2 there, because you're going to discount like what's the chance it's going to be there. But if there are 50, you might actually be able to reduce the number of parking spaces, right, safely. And a parking space on the surface is called $20,000 or $25,000 a space, which is rapidly where the price of the EVs is going. So if you can sort of transition, just like I think somebody else had said, take the money that would have gone into the transformer and instead put it over here. We'll take the money that would have gone into building the physical space and instead buy an EV to fill a different space and reduce the, like once you start getting up at these numbers, I think you will be able to safely reduce your parking, because I don't feel comfortable reducing parking with token numbers, but at these numbers, that's something we're looking at. So
Yeah, we're into the realm where statistics is our friend here.
yeah.
That's an important consideration, definitely. Yeah, it's something we can definitely look into further. Real quickly, this is sort of a rough outline. It is still a solution in development, but we're currently the breakdown of the different electric vehicle chargers is going to look something similar to this. Our first product there is the Fermata FE15, which is a bidirectional charger that can equip, that is already licensed to, or approved, pre-approved to be to work with the Nissan Leafs, excuse me. So as a common bidirectional electric vehicle on the market, the Nissan Leaf is sort of our focus as well. We also have for variants for the different models and different charger types that come with different bidirectional vehicles. We have some of the InCharge V2X or the ICE V2X model, which actually is a 22 kilowatt charger that has 2 plugs for consecutive charging of 2 different vehicles, which will reduce the overhead cost of installing the charger towers and these parking lots. But those are versatile, so they have different plug types that can service different types of vehicles. And then, as we said, we have the one Ford Charge Station Pro dedicated to the Ford F-150 Lightning that will be used for the community center. And then lastly, for the other spaces, these are going to be monodirectional chargers. And so there will be most likely the Nuve, since they're most experienced in fleet development for electric vehicles, but once again, still in development there. But the numbers should be about 89 spaces that are either EV installed or will be EV ready in the future as per code requirements. So, but yeah, that about sums it up.
There's one more slide. Yeah. This is, super brief. This is just saying there's more to come, but right now we're seeing a 93% savings in energy costs for the owner, and then 92 operational carbon emissions saving. Including the solar and battery, and we're also meeting our embodied carbon target as well. We didn't really touch on that in our presentation. But I think the coolest thing we're trying to do is do a mass timber frame for the carport solar. So that's the coolest thing. Anyways, now it's done. Woo!
One last question. What's your total overbuild factor, solar production during the year compared to building consumption over a year?
Oh, I think the number is somewhere around 10,000 kilowatts per day. So during the summer months, I can go back to that slide.
Yeah, not a huge deal, but I just I love that. If anything, try to start shifting the conversation away from curtailment, because it sounds like a wordy dirt, right? And I think the dark money from Coke to Puss Network is criticizing renewable energy for having to be curtailed, but the natural gas fleet is curtailed over 80% of the time. Why do we let them tar us with a nasty brush? So talk instead about smart overbuild. We always design for the worst months, just like the natural gas system has, and don't let those rotten
I think Tony.
strategic overboard.
Yeah, so Tony Seba, who does analysis, talks about this. I think he calls it superpower.
There you go.
You talked about tenant education a little bit. Got me thinking about the induction stove thing. I was wondering if like that specifically was going to be something, since maybe a lot of folks aren't familiar with how to use them or what cookware they can use with them, and just in general, since it's a very different project. Like, what is tenant education look like?
Well, that's the EPRI team has been working on that, so we weren't as involved, but induction cooking should definitely be included in that. And I think the biggest thing we wanted to say is like, just because you have an off-grid building doesn't mean you can have like 20 fridges in your apartment, like try to mitigate a little bit so like the worst of winter days aren't like horrible, right? So still educating on energy efficiency too. Yeah.
Do you have any feedback loops for, knowing how you're doing in the winter, in terms of...
Yeah, we, if we're awarded, part of the budget is going towards energy monitoring, so we're supposed to verify our EUI when all is said and done.
Look, truly, if the sun is out, we have more than enough energy.
Yeah.
If the sun is not out, we don't have enough in the wintertime, but if it's out, we have too much energy. So it's pretty much the easy thing. Oh, it's a sunny day. Oh, it's cloudy. I guess maybe not today.
Have you chatted with PG&E, and if so, what's their perspective on this sipping? So what they might charge you for the right to do
So I went through a bunch of staff at PG&E, and what I got down to was they are satisfied with this unidirectional connection. That's a thing. There's a standby rate power, so we're not going to be using it except every once in a while, so it's standby.
Yeah.
And that they would allow off-grid. If you want to build off-grid, you just can't. PG&E is not involved in that. The city of Petaluma would have the control on it as the building department, and they're okay with this. So we kind of covered the bases.
Okay.
And I don't know, PG&E, they hate rooftop solar. They get in the way of everything that reduces their profit margin, so I'm not expecting them to.
Well, and just this model is not what they want. They don't want to be operating a grid for a bunch of sippers. They want some big...
Yeah, well, we're trying to make it disappear. Like, whenever they're operating a grid,
chuggers.
right? Once we're only sipping a little bit in the winter, like a 200 amp connection just 3 weeks of the year, that's 5%, roughly 3 weeks total. So it's like a single family house, which is a 200 amp connection that only turns on for 2 weeks in the winter. How can they complain? Have we done any harm? By contrast, in Petaluma, the same city, this year, a developer client of ours, affordable housing, was rejected for building permits from PG&E after a 3-year process because they said all of the accessory dwelling units that are going to be built in the future in the subdivision around you for all the wealthy homeowners take priority over your existing today building permit affordable housing. We're not going to give you power to save it for the ADUs in the future.
That was also
That happened. We had to get politicians involved. So that's in the same town only a few months ago. Like every week a meeting with the whole team. What are we going to do? And we're coming up with some of those strategies at the same time. Like, well, on this research team, we can put one a battery and give us more power. But it's like a real problem in Petaluma specifically.
I will say like this portion of the grid where the building is located is pretty constrained as well. So we're kind of offering them a solution.
Thank you.
So is there any thought of, I told you I'm working on a little off-grid house. Is there any thought of like, power, it's raining for a few days and, battery's low, you need power, you're gonna take power out of the cars and telling everybody, hey, go to the mall and recharge your car.
Go across the parking lot to our grid-tied chargers.
Yeah, oh, okay.
It's like, so really we can export energy into the grid from across the parking lot. Or they just, on any sunny day, they could charge up and give us 10 kilowatts to the 60 they gave them the day before. Like they shouldn't have to go anywhere.
Right, but I'm thinking, the worst case, like
Worst case.
5 days of rain or something like that, right? Now my car's getting low.
I know, but they got $1,800 of free driving every day of the year. They drove for free, which we all know is like this humongous energy burden. So it's like.
But what happens on that day, they had something really major important to do.
There is the grid tie chargers.
Yeah. And we're only taking 10 kilowatt. Okay, so we learned that vehicle to grid participants want no less than 80 miles of range. 80 miles of range is about 25 kilowatt hours, 24 kilowatt hours. out of 60. So we're assuming we're gonna take only 10 to 12. So we are thinking we're taking whatever, like a 20%, something like that. It's a small amount. And we're never gonna take more than their 80-mile reserve. It's part of the vehicle to grid controls, so we don't empty their battery enough to go to work and home for about 2 days. That's what 80 miles is.
I believe the survey that you're referencing was actual, like vehicle owners who were participating in a program and then were surveyed. The survey was ultimately getting at the concept that I believe they were using Nissan Leafs, and half their battery provides them. Yeah, I mean, don't quote me on like what year this study was, but the main concept or like the main takeaway in that specific part is that the idea of telling them you have 50% of your battery remaining, that sort of alarms people as opposed to telling them you have 80 miles of range left. So that was really more about contextualizing it so that people understand how much their battery capacity will actually get them, rather than just telling them this arbitrary, oh yeah, we'll leave you with 50%, and people were less comfortable with that. So just definitely 80 miles of range. We also looked into, I think the average person drives more like 37 miles in a day, so 80 miles is more than compensating for the daily driving habits. Did that answer your question? I hope.
But in order to be fair to Christine, we got to get Christine up here. So this is our last presentation of the day.